Good morning, and thank you for joining our webinar today. For those of you that don't know me, my name is Paul Sirico, and I run marketing and product strategy here at FieldComm Group, and we're the sponsor of this webinar today. Today's topic is going to be called How to Develop and Register a WirelessHART Device. I'm going to kick it off a little bit by introducing some of the speakers, and then the balance of this is going to be talking about other topics related to WirelessHART development, and we're going to close off with some applications of WirelessHART technology. Finally, we'll do a question and answer session. I'm sure that you'll find this to be a very informative broadcast, and please get those questions ready. You can enter them in the question chat box in your GoToWebinar control panel, and we will. We've got a couple of handouts that we've included as well. Take a look at those and download those. And without further ado, we'll get going. So who's going to be speaking with us today? Let's talk about that a little bit. You'll see a few guys hopefully up at the top of the camera here. The first is Robert Asamidi. He's going to kind of be the keynote. He's going to be walking through the process of developing a WirelessHART device. I've known Robert for many, many years. We go back to, gosh, maybe the early 2000s and the ISA 100 development process. He's been with Centero, and he's the co-founder of Centero. Centero is a FieldComm Group member company, and their specific area of expertise is device development. They develop products for other companies, and they've developed a lot of the WirelessHART products that are registered and available in our product catalog. So if you're interested in maybe taking an existing device and getting it converted over to WirelessHART, he's your guy. He's going to be doing a lot of the talking here, and he's going to walk through some of the things you need to consider when you are developing a WirelessHART product. Next up, after Robert, we'll be hearing from Philippe Mook. Philippe is also a great guy. I'll apologize in advance for his Belgian accent. You know, he's from Belgium, as you can see here. He works for Armstrong. Armstrong does a lot of steam trap monitoring. They're located in Michigan, and they have a great wireless product that has been, you know, around for several years now, and has been deployed in a lot of big name companies. And then finally, we'll have Chris Frail. Chris is from United Electric Controls. They're based out of Boston. I have a particular affinity for Boston since I lived there for 25 years or so and raised both of my kids there, and used to play golf right across the street from Babson College, in fact, where Chris got his business degree. United Electric Controls makes a WirelessHART gas detector. He's going to talk about some interesting applications of that technology, and once he's done, we'll put our video cameras back up, and we'll be available to take questions for you. So again, put those questions into the box. And for now, I'm going to say, take it away, Robert.
Thank you very much, Paul. Thank you for the very, very flattering introduction as well. Well, thank you all for joining. Right from the start, let's start with a few WirelessHART facts. So the standard itself, the WirelessHART standard, has been architected to meet requirements for industrial process automation. And it was really architected specifically, and I'd like to highlight that, to meet industrial process automation requirements. There are quite a few industrial IoT standards-based technologies out there, but just to reiterate that WirelessHART was specifically developed for wireless process automation. It has been approved, it has become an IEC standard, a worldwide IEC standard in 2009, and it is built on the solid foundation of the HART protocol, which, as probably most of you know, has been around since the 80s. At this point, there are about 50,000 plus WirelessHART networks deployed worldwide, and this is one important fact. WirelessHART uses the same application layer as wired HART. Now we will talk a bit more about that in some of the other slides that will follow, but that's something that I would like you to keep in the back of your mind. And just a few words about the FieldComm Group. The FieldComm Group is tasked for with maintaining the HART/wireless HART specifications as well as other specifications. And also, they are also running an interoperability program. So it is the FieldComm's responsibility to ensure that all instruments and infrastructure devices that are wireless HART compliant do interoperate, and there is a registration program that is specifically designed to ensure that whenever you buy a registered FieldComm instrument, wireless HART FieldComm instrument, it will interoperate with the gateways out there, as well as with other registered FieldComm wireless HART instruments. Now, why choose wireless HART? As mentioned earlier, there are quite a few IoT standards out there, but why wireless HART? Well, first of all, wireless HART was architected with reliability in mind. So reliability was one of the key requirements, I would say the keystone requirements when wireless HART was being standardized. We're looking at 99.9% uptime in well-formed networks. And how is this reliability achieved and ensured? Well, it is ensured through various mechanisms that are part of the actual standard. Path diversity, which really means mesh routing. So all instruments are able to send their application payloads via several different routes. In case the primary route, if one of the routes goes down, or the link between the instrument and its primary router goes down, the data will be sent through an alternate path. Time diversity. Wireless HART uses TDMA, meaning that time is split in 10 millisecond time slots, and each device knows exactly what it has to do in every time slot. And that is ensured by the network manager, which is a software entity that runs in the gateway. Frequency diversity. In wireless HART, all field instruments do hop on all 15.4 defined channels. Now, let's move on to interoperability. At this point, there are 27 registered devices from 15 different device manufacturers. The application layer is fully defined and understands and well understood, since it is based on HART, as I mentioned earlier. Wireless HART uses the HART application layer, which has been around for quite a while. And let's see, interoperability with existing control systems, that's also ensured through the interoperability and registration program run by the FieldComm Group. Cybersecurity, that is on everybody's mind these days. And wireless HART does include, it's based on a two-tier structured security system. Security protocols are mandatory. So at the bottom of the OSI stack, we have a data link layer hop-by-hop authentication, which terminates in the gateway, and then also transport layer authentication and encryption. I'm sorry, the data link layer hop-by-hop authentication terminates in the access point, and the transport layer authentication, it's an end-to-end security relationship between the field instrument and the gateway, and that terminates in the gateway. Moving right along, scalability. So we're looking at hundreds of devices per network. The mesh networks are self-organizing, so you don't need to necessarily have a line of sight between instruments on layer 1 and the gateway itself, or the wireless access point. It is a deterministic technology, and what we mean by that is that the network manager, as I mentioned earlier, actually tells each device what to do in every time slot. Now, why is that important? It is important because that is the only way to ensure latency guarantees, or to guarantee latency, the arrival of particular data payloads within a certain guaranteed latency, which is a very fundamental and important requirement in wireless process automation and control. Full data context. We touched on this a bit earlier as well. The application layer data structures have full context, meaning that, in addition to the data received, they also include additional data that maximizes the value for data analytics. Publish by exception. So the instruments themselves publish data periodically with a preset periodicity. And what this allows us to do is it allows us to extend the battery life of the field instrument. And we will talk about battery life in a little bit here as well. So this is a quick reference guide that gives you a snapshot of all the steps involved in developing and registering a WirelessHART field instrument. The first step will be product definition, architecture, and project planning. And as a first step, what you would do is you define the product requirements. And this does assume a basic understanding of WirelessHART features and mechanisms. At that point, you would be asking yourself, do you want to develop a WirelessHART field instrument or a WirelessHART field adapter? This presentation and the white paper that we published earlier this year kind of applies to both. Now, it is during the product definition that you would also ask yourself what your application layer functionality would be. Do I need to publish? Am I involved or engaged in supervisory monitoring? Or will my device be engaged in control? What type of PVs, process values will I be publishing or sending? You will also, at this point, you will also choose your sensors, or if you don't control your actuators, a battery source, which could be, so your instrument could be battery powered, which the vast majority of WirelessHART instruments are battery powered, line power, or even harvester powered. And you also, during this phase, you would also, it is highly recommended that you also think about operation in hazardous areas. Are you defining an intrinsically safe instrument? What type of classification will this instrument have? Because that will have a significant impact on your development process. This, just before we get started and go deeper into the development process, it is important to be able to identify the different entities that are part of each WirelessHART field instrument. So this illustration here gives you a snapshot of the internal anatomy of a field instrument. So what we have is we have a wireless module which runs the WirelessHART communication stack. And that includes everything from the physical layer all the way up to the application layer. And the second main entity is an application processor. Now, what is the responsibility of the application processor? The application processor just runs application-specific functionality. It connects to sensor actuators or to other peripheral drivers. It also typically includes a power optimization engine scheduler. Now, why is that important? Because it is this power optimization engine scheduler that will dictate or ultimately influence the battery life of your instrument. And last but not least, each WirelessHART instrument needs to include a FSK maintenance port. The maintenance port allows plant personnel to configure the instrument using via a wired HART FSK port to where they will connect their HART maintenance tool to this port and be able to provision the instrument. And what I mean by provisioning is, inject the network ID, security keys, and also also issue HART commands via this maintenance port. So kind of already went over this earlier, but yeah, the application processor does implement the HART application layer, connects to sensor and actuators. Yes, it's very important. It is the application layer that will burst or periodically publish the application, the process values and status data to the gateway. The application layer manages the maintenance port I mentioned earlier and the battery life. Well, monitors and manages battery life. What does the wireless module do? The communication stack runs on the wireless module. It complies with IEEE 802.15.4-2.4 gigahertz. which is the underlying WirelessHART, the underlying wireless physical layer that is utilized by WirelessHART. It is also responsible for precise time management. So when you run this deterministic wireless network, it is very important that all instruments, all devices, all entities that are part of the WirelessHART network stay very tightly synchronized in order to respect the boundaries of that 10 millisecond time slot that I mentioned earlier. The wireless module and the stack is also responsible for device security, which is very helpful since the application layer does not have to do much, right? It also routes packets and sends data on behalf of other instruments that are part of the network, and is also obviously responsible for joining the network and managing this mesh connectivity. So to that purpose, this is Centero's WirelessHART module. This was a wireless module and is a wireless module that was developed by our company, Centero, specifically for industrial process automation. It does run a WirelessHART communication stack that is compliant to HART 7.6. It does include a reference implementation with all the components needed to develop a certified instrument. Now, one thing that we're very proud of, it does boast a market-leading sensitivity of -108 dBm. So once you add that to the 10 dBm output power that WirelessHART allows you to transmit with, you get a link budget of about 118 dB. Now, this helps a lot when deploying instruments out in the field, as it allows you to extend the connectivity between instruments and minimize the hop count. And what I mean by that is, in a mesh network, ideally you would keep the depth of the mesh layer, the mesh network, as shallow as possible, because the more mesh layers you have, the more power the intermediate routers would have to eat up in order to route data on behalf of the devices that are positioned in the deeper layers. So extending range is important because it allows you to keep the networks more shallow to where you have more connectivity range, shallower networks, so your overall power consumption of the instruments is lower. It is designed specifically for inclusion in intrinsically safe instrument. It does have an onboard adjustable RF front-end module, which allows you to adjust the power up to 10 dBm, and also a selectable RX gain mode. It is very small, suitable for inclusion in real estate constrained products, and it has been tested for interoperability with various different gateways and infrastructure devices provided by other vendors. Now, moving right along, developing a WirelessHART field instrument does require that you have a multidisciplinary engineering team. Now, why is that? It's because you have to have a basic understanding of wireless in general, and then a basic understanding of WirelessHART, well, HART and WirelessHART in particular. And to that effect, the FieldComm Group does offer a gamut of different development and validation tools, which are listed here. Now, these tools are very useful when developing a WirelessHART field instrument, such as a HART physical layer test kit, a HART test system, a WirelessHART test system, the Y-Analyst packet sniffer, which is used quite extensively when developing a WirelessHART instrument, an FDI device package, and various different HART IP clients that allow you to develop client applications that will communicate with the gateways that you'll be using. Now, moving on to step number 2. At this point, you would develop your functional prototype. A WirelessHART development kit will definitely greatly accelerate your development process, because otherwise you would have to write everything from scratch. And WirelessHART development kits typically do include all the elements you would need to quickly develop a WirelessHART instrument. It includes the wireless modules, development boards, gateways, and so on and so forth. And to that extent, for that purpose, Centero also developed a WirelessHART, the WirelessHART development kit, Now, this is a comprehensive end-to-end development kit and platform, and that allows you to quickly develop WirelessHART field instrument. So it does include 2 spin development boards, which you can see up in the left corner. These development boards are quite versatile. They include the WirelessHART module, as well as an application processor, which you can see on that Arduino board, on the white Arduino board, which is plugged in the upper left corner of the board. And most importantly, it includes source code for the application processor, right? To where you wouldn't have to write this from scratch. This application processor source code package is provided with the kit. It is royalty free, so you can really develop as many instruments as you want without having to pay us any license fee. The kit also includes a gateway, a WirelessHART gateway, which is field ready, C1D2 and ATEX rated. And last but not least, the gateway also includes a very feature-rich monitoring and control software, which allows you to interact with prototypes that you are building. Let's move on to the next step, hardware development. So at this point, you're pretty much ready to start developing your instruments. So what you would do is once you have, using our kit, you can very quickly set up a prototype to where the kit comes pre-configured to where the instruments, the development boards do connect to the gateway. And at that point, you would just decide what sensors you would want to connect to this application processor. I forgot to mention the development board also includes a bunch of different sensors, a temperature, humidity, pressure sensor, an LED which can be used to simulate control. But that's all part of the source code as well. And once you get your hands on the source code, all you'd have to do is really, modify that source code to tailor it to meet your needs. But since we're already publishing these sensors, we're publishing and controlling these sensors and LEDs, that gives you a very good starting point to where you just have to really change the code to publish your particular process values that you'll be interested in. So let's move on right along. So now you're ready to start your hardware development. At this point, you would have to go through the battery selection process and select a battery that meets the power budget for your particular instrument. What we typically see is, lithium thionyl chloride batteries that are being used in instruments of various different capacities, or some kind of lithium-based batteries. You would have to, as mentioned earlier, you do have to also include a hardwired maintenance port, FSK maintenance point, along with our kit. As you can see over here in the right corner, down here, it's kind of hard to see because we also include a reference design for a hard maintenance port. And when you purchase the kit, you will get the schematics, the layout, the bill of materials. So at that point, you really have 2 options. You can drop the hardware design for the hard maintenance port on your board, or you can purchase these hard modems from Centero. RF considerations. You should be able, your power supply should be designed to where it will allow give enough current or provide enough current to the wireless module to transmit up to 10 dBm. And then what you also have to consider is your antenna selection, because the FieldComm Group will check out the antenna propagation patterns for the antenna you have selected when you go through the registration process. Enclosure selection, this is highly influenced by a decision that you made during the product definition phase. If this is an intrinsically safe instrument, then you would obviously choose a different enclosure than if it was an explosion-proof instrument. Firmware development. You ready to start your firmware development? So this point will go to the FieldComm Group and kindly ask them to assign a manufacturer and device ID to your organization. If you are a member, you most likely already have a manufacturer ID that was assigned to you. And during the firmware development process, you will be focusing on 2 facets. One, integrating a wireless module with your application processor. But that code is already included in that application processor source code that I mentioned earlier. And then secondly, you would map the sensing and control functionality to HART and WirelessHART commands and various mechanisms, such as the publish mechanism or the bursting mechanism, which will allow you to periodically publish these process values anywhere from 500 milliseconds with a periodicity of anywhere from 500 milliseconds to a few hours. Next, you would validate your firmware with a WirelessHART gateway and ensure that your process values are being periodically reported and correctly and reliably reported to the gateway. And it is also here that you would go and do your battery life fine tuning. So in order to achieve anywhere from 3 to 10 years of battery life, these instruments have to be quite fine-tuned quite well from a current consumption point of view, meaning that the radio module itself spends most of the time in sleep mode. It will only wake up whenever it needs to transmit or receive something, or to receive an advertisement from the gateway or other instruments, for example, in order to maintain that precise time sync that we mentioned earlier. But it is your application processor that will ultimately, the application processor and the sensors that you connect to this application processor that will ultimately dictate the battery life of your instrument, because your application processor needs to wake up and interact with the sensor or sensors of actuators, which in turn also draw current. So it is here that you would do some battery life fine-tuning and run a battery life optimizing schedule to where you ensure that you do not wake up the wireless module when it's not needed, because you do have the capability to wake up the wireless module at any time, the WirelessHART wireless module. But it is here that you would actually write some sort of a power scheduler to where you would fine tune when you would wake up the application processor, read your sensors, or send packets to or control your actuators or your relay outputs or whatever you're doing, and also sync with the WirelessHART module in terms of publishing the data that you've collected or receiving data for your actuator. Now, once you've done all that, or you're ready to move on to software system integration. So at this point, you have a good understanding what your instrument needs to do. So for each field instrument, you will need to develop a HART device description file. This HART device description file, it exposes the capabilities of your instrument. It really tells the DCSs or the entities that are running on the plant network what your instrument is capable, what values are being reported, what type of diagnostics you are reporting. It basically models all the capabilities of the field device. Now, you can also develop an EDD, an enhanced device descriptor file. And FieldComm does offer the FDI device package ID, which will allow you to develop this file. Or you can come to us to Centero and we'll help you develop this file. Let's move right along. At this point, if you have developed your instrument, you validated your instrument, you have written the DD file, you are most likely ready to submit the instrument for FieldComm Group device registration. In order to do that, you have to be a member, a FieldComm member. And there are many advantages of joining the FieldComm Group as a member. You get to shape future industrial IoT technologies. You get discounted pricing for training, development, compliance testing, registration tools. All of these are provided to you at discounted pricing. And you will also get prioritized access to from the FieldComm support team. You will also purchase the test tools from FieldComm, which include a complete suite of protocol-specific tools that also include test automations in some of these tools. And before submitting the registration package to FieldComm, you would most likely, or it's highly recommended, that you run some internal registration tests in order to ensure that your device will pass all of the tests that are being run as part of this FieldComm device registration process. So when you're running this internal test, you would collect all the test logs and results because you will need them for your registration package. And here's a list of the tests that are required or are part of the FieldComm registration tool. So what does the FieldComm do? When you submit, you send a couple of instruments to them, and they will look at your physical layer test, the physical layer. They will include that your FSK maintenance port is compliant. They will run some data link layer tests, which include the token passing DLL used by the maintenance port. Then they will also test the WirelessHART or the wireless facet of your device, which includes a bunch of different WirelessHART specific commands that were added to the original HART protocol. They will check your universal commands over both the wireless channel as well as the wired FSK maintenance port. Same for the common practice command testing of the wireless channel and maintenance port. They will run system level tests. Now, these tests are designed to ensure long-term operation interoperability. And the FieldComm also offers these tests separately from the actual certification process. And I would highly recommend that you do use their services because it is a long-term test. If I recall correctly, it takes a few weeks. They'll really leave the instrument connected to the test system and ensure that your instrument is also reliable and fully operational for a longer duration. And then along with your field instrument, you will also submit your EDD file. So once your product registration kit is ready and you have all the test logs and results and the supporting documentation, as well as the DD file and the wireless compliance documentation, you would submit this to FieldComm, place a purchase order, submit 2 devices for registration testing, and the FieldComm Group, their team, will test your instrument fairly rigorously and confirm that all your registration tests have successfully passed. Once that happens, the DD file is sent out for testing with various host systems. As I mentioned earlier, the FieldComm registration process also ensures that your field instrument will interoperate with host systems out there, with various different gateways and host systems. And once you've passed went through all these steps, your instrument will be your device will be registered and listed on the FieldComm Group website, and the DD file will be available for download on the FieldComm website. Regulatory compliance and certification. Although this is listed as the last step during the development process, this is definitely something that you want to keep in mind throughout the entire development process. If you choose, well, obviously the operation in the hazardous area or the classification of your instrument will dictate the way you design your hardware, your enclosure selection, your antenna selection, and so on and so forth. Now, from a wireless EMT compliance point of view, the module itself, so the module that Centero offers, has already passed modular certification in the US. It's also been tested in the European Union under the ETSI 300-328 rules, Japan, and so on and so forth. But in addition to that, since you are integrating our module into a product, you will be required to run additional tests, such as FCC subpart 15, which is called an unintentional radiator test, the way you just demonstrate that you're not negatively affecting the operation of the module, which already has FCC approval or EU approval. Same in Europe and Japan. Actually, in Japan, I don't think you have to do that, but there will be some additional wireless compliance tests that you'll need to run at the product level. Again, the wireless module is already certified, so we ensured that it meets all the requirements. But what these wireless compliance tests are intended for, what they're intended for, is to ensure that your power supply or your instrument does not negatively affect the operation of the module that was already certified. Some additional regulatory and compliance tests that you will want to consider are some additional immunity tests, ESD, and safety compliance tests. And depending on the complexity of your instrument, you would have to, well, if it's an intrinsically safe instrument or if it's an explosion-proof instrument, you will definitely have to consider that these tests will take a while and they're typically not very cheap. So this is definitely something you want to consider from the very start when you define your product requirements, which are obviously driven by end users and market demand. So in conclusion, if you plan to develop a WirelessHART instrument, to contact us or the FieldComm Group, and by us I mean Sentero or the FieldComm Group. We have a development kit that you can purchase that will greatly reduce time to market and minimize the cost involved for you, to where you wouldn't have to necessarily become a wireless and WirelessHART expert and write your own application code. You will have a very good head start if you utilize or buy our development kit and our wireless modules. And last but not least, I would like to highlight the fact that if you develop a WirelessHART instrument, you will reap the benefits by having access to more existing industrial wireless field device networks and host systems than any other industrial IoT protocol. And with that being said, I would like to thank you for your attention. Feel free to contact either the FieldComm team or contact Sentero directly if you have any other questions. We also offer engineering services that would allow, well, we can design the product for you if you don't have the necessary knowledge or teams to do that. And that will also probably help you launch your product quicker and in a cost-effective manner. I would like to thank you for your time. And with that being said, I will turn the baton over to Philippe Mook from Armstrong, who will go over the steam trap and valve monitoring application use case.
Yeah, thanks, Robert. Thanks for the detailed presentation. Brings back a lot of memories. So, in my short presentation, what I would like to highlight is the two applications. One is the steam trap monitoring. The other one is valve monitoring, and specifically safety relief valve. So, first, the main question is, why wireless monitoring and why monitoring? So, first, why monitoring? On steam traps and safety relief valve, for example, you typically check them once or twice a year. Means that you could check it and it's okay, and then it's failing the next day. And in case of a steam trap, might be blowing steam for the rest of the year, or a safety relief valve might discharge fugitive emission to either the atmosphere right away. It could go to a flare, and you have a big flame on the flare, and you're wondering which of the 100 valves that you have is open. So the wireless monitoring allows you to do 24/7 monitoring against the point of time. You quickly identify where is the failure. You also, the wireless against the wire, typically in steam trap and safety relief valve, they are all over the place. So if you had to run cables and get all the wire connectors everywhere, would be the cost would be really prohibitive. So you see that quickly, with the wireless monitoring, you cut the labor cost to have them quickly at the place that you want to monitor. You also have your more maintenance resources, because instead of checking those traps or valves once a year and having 90% of them okay, this is kind of a waste of time. Now you are only focusing on the one that are failing. So steam trap monitoring first, and why should you do steam trap monitoring? And there is basically two types of failure on the steam trap monitoring. So if you look at the whole steam system, you start with the boiler, you have steam distribution, the users, and the condensate return. The first failure is a steam trap failing open, and that's the most obvious, because when it's failing open, the steam trap is actually basically blowing steam, and with the cost of energy today, it's very costly. You are just losing steam. It's going either back to the condensate return line, then you create back pressure, or it's just going to the atmosphere. Another one is when the steam trap is failing close, and it's typically the most costly. It's hard to calculate the cost. A fail open, we know the cost of steam, so we can evaluate the steam losses. But when it's failing close, you start having, the condensate backing up to the system, the distribution, And then you start having wet steam, flooded heat exchanger, water hammering in the heat exchanger. You have non-combustible gases in the system. You start having corrosion with carbonic acid. And it's typically the most costly, because if you have to replace a coil in a heat exchanger, it's typically more costly than just a steam trap. And so this is typically, the things that people are not really looking. But if you go up north, like here right now, I'm based in Michigan, but if you go to Canada, they have frozen pipe. And we had that in Texas. They had a big freeze, and we had to replace hundreds of traps that actually just exploded because they froze. So being able to monitor them 24/7 allows you to act quickly and fix the issues. So Armstrong has been doing wireless monitoring for steam traps for more than 20 years. We do steam trap management because every year 5 to 15% of the trap will fail. You increase the efficiency, there is a payback, and it's here 6 to 10 months. I would say nowadays with the cost of steam, you can probably go down to 2 to 3 months of the return on investment you replace the trap. You have the opportunity to standardize, and there is the quick wins of energy savings and less maintenance. So Armstrong, more than 10 years ago, developed a WirelessHART device called the AIM, Armstrong Intelligent Monitoring. It's non-intrusive, class 1, div 1, zone 0, that Robert was highlighting, all the certification that you have done. You see here we use the 4 variables, though the PV, which is the primary variable, that's the one we use for steam trap condition. So 1 is okay, 2 cold, 3 blow through. The algorithm is built into our device. So it's very easy on your DCS to take, 1 is green, 2 is blue for cold, and 3 is red for blow through, and you get the information right away. As today, the ST5700 device is the only hard register steam trap monitoring device available. You can easily, and we always recommend people to go on the FieldComm website to look for registered product to make sure they comply with everything that FieldComm is asking for, and that you have a device that will not be an issue on your network. So always look for hard registered devices. The next application is valve monitoring. So the main is on your fugitive emissions and leak detection, and the importance is actually to identify the source, the time, for how long, and the magnitude of a release. If it's just sizzling, or is it just wide open? And this is what you really want to do. To do that, there's actually 4 advantages of doing the valve monitoring. If you go on the next slide, and there is the safety. Because reduce exposure, and Chris just after me will also explain about gas detection, which is more when it's leaking from flanges or leaking directly in the atmosphere. On the valve monitoring, it's typically when it's blowing inside the piping. So for the environment, you also reduce global warming and greenhouse gas emission, because now you can know if the trap is failing. On the economics, it makes the process more efficient. You're limiting downtime and reducing losses. And legally, quite often you need to pay fees when you have fugitive emissions. And typically the fees are calculated based on the time when you did the last survey. So when you test, so if it was 6 months ago and now you found out it's leaking, you pay for 6 months. With a valve monitoring wireless 24/7, now you know it's failing, you replace it right away, and you can reduce the fees. So that's why Armstrong developed also a WirelessHART devices, which is specifically for valves. In this case, it's safety relief valve, but we do all kind of valve, bypass valve, blowdown valve, stop valve, you name it. Anything you need to monitor if it's open or closed, we can monitor that with the acoustic. And we have multiple variables, 0 to 6. With one, the first one being the level of the sounds. We have the temperature, we have the number of occurrence. So depending on how often you test the sample rate, we can calculate the number of occurrence and calculate the total time that the lift is detected. We have the battery life, and also the acoustic level threshold that you can adjust, and the sample rate. 6 variables, 7, sorry, 0 to 6. And so you can actually select what you want to see on the PV, SV, TV, and QV. That's up to you. That model, the 85,000, is also class 1, div 1, zone 0. Non-intrusive installation. It's just a clamp. It's hard registered as well, like the steam trap monitoring, which comply, and you make sure that you have a device that is safe on your network. And so you can easily now monitor any valve, any place. Next. Now let's Chris introduce on the gas detection, and up to you, Chris.
Thank you, Philippe. And thank you to the FieldComm Group and Paul for thinking of us to come talk about some applications. What I wanted to talk to you guys about is kind of a little bit of the evolution that we've seen in safety gas measurement. Robert, you put the next slide up. So what we have is a wireless gas detector, and it's actually surprisingly similar in terms of the approach that Philippe just talked about. Is you have a point sensor, a data point that you want to get, but at the point you may not have wiring or available power or the ability to scale up a wired system to really achieve that. And what battery operated devices allow you to do is now start peppering a lot more data points into an existing system to enhance the diagnostics and understanding of what's going on in the plant to help prevent leaks or identify leaks sooner. And it's kind of interesting to hear how Philippe and the team at Armstrong can predict it. Often sites would like to also have a lot more gas detectors at site to try and detect gases before they become a large enough plume that an ignition source would be found and become a damaging explosion. Wire detectors are very prominent. They're been around for decades and are used in integration with a fire and gas system. And the reason more recently wireless is just becoming viable is because of the evolution of technologies. One being battery technologies have come a long way in the last decade. Sensor technologies traditionally have been very high powered and drain batteries very quickly. So you would typically have battery operated gas detectors as only personal monitors, or during a hot work permit, a handheld or an area monitor, but never really considered for long term. And those two pieces have come together now, and you can get to where we're at right now is 5 years a minimum for the NDIR sensors for combustibles, and then toxic gases could go longer. But the one piece that was always a resistance is because it is safety is wireless reliable? Where can I get support for wireless? How can I know that, be confident that it's going to work without failure or loss of signal? I think Robert did a great job talking about how the mesh networks are set up correctly. You have 99.99% uptime. You have all the data available from the devices. You have multiple ways to get back to the gateway. You don't need line of sight anymore. And then the ability to actually then, if you design it as described, to design it such that it's interoperable with any other manufacturer. There's 15 manufacturers that are registered to work with WirelessHART. So now you can plug in a detector anywhere there's infrastructure. And that has given a lot of confidence to the industry to start applying these in a safety application such as gas detection. And you scale them up pretty quickly. Now you can start talking about deploying a lot of detectors in covering a lot of areas where maybe it wasn't cost effective to put a gas detector, instead just put mitigation should something else happen. Unfortunately, fire suppression is where you've got to put a lot more money in, because you have to make sure if something gets ignited, you have to get that under control quickly. And then gas detection is, put it where you can, and then hopefully get a lot more density of the measurement. And what wireless is really doing is enabling that, giving you a scalable, cost-effective way to get a lot more points of data, so that hopefully you can detect that gas plume long before it becomes a dangerous size that can actually cause real damage, and then address that issue before it gets ignites. So what I want to do is give a couple of examples of how customers are using that and gaining confidence in it. The first one was a Coke manufacturer that basically supplies Coke to the steel industry. And as a result, you can have a lot of H2S present in these plants. And they have a lot of wired H2S detectors, But what they were having was a reliability issue specifically associated with conduit and wiring, not necessarily with the detector or sensor itself. So they were spending a lot of time doing maintenance on the wire detectors to actually make sure that they continue to be operating and reporting. So they needed to find a solution that they could put in and not have to worry about the detector as much, and more rely on the information that it was providing, that, hey, there's a high level stress in a particular area of the plant that needs to be addressed. They came across us when they were in need to put in one quickly. They felt as if initially it's wireless, we'll do it temporarily. And we put one in, and they were very happy with it, that they are now looking to replace all of their wire detectors with wireless, because of the simple fact that they don't have to maintain the wires anymore. They don't have to worry about conduit if something got damaged or leaked into, and the corrosion occurring to the wires themselves. So they're actually finding that the wireless detectors are much more reliable than the wire detectors. And they're starting to spread this out to other plants. So they're able to get it up without any disruption to operations. They were able to plug it into their existing WirelessHART infrastructure, and they had the confidence it was going to work with their gateway because of the fact that it was a registered device and proven to work with other gateways. For example, when I met Robert more recently, he provided us with the Centuro gateway, and we were able to get it working, that afternoon without any experience of using it. And now we continue to see how much, how further we can push that device. That was very important to them, and now they're scaling up. This is another example on the next application. This is similar. It was at a refinery here in North America, and they had a lot of wire detectors that were reaching their end of life. They were in the tank farm where the spherical tanks were. In order to replace them in kind, they would have actually had to trench all of the conduit and put all new wire in, because the wiring itself had also reached, were no longer serviceable or at end of life as well. So they'd have to run all that conduit. They weren't having necessarily the same problems as the Coke manufacturer, but the simple fact that the age in conduit and wire was so old, they needed to replace it, and they wanted to try a different solution with the wireless because it was now available. And they tested out about 10 of them, very happy with the results. And now they're able to start replacing all of the wire detectors that are coming to end of life with wire detectors. But what they realized very quickly is they were able to scale far more than just what they had for the wire detectors. So where they might have had 4 detectors before, they're finding opportunities to put in 10 detectors to get better gas coverage. So they're able to scale this up pretty quickly, and now they're looking at other parts of the plants that they feel they could do for better coverage and driving that more. And again, their scaling is up very quickly. They don't have to do the wiring, but they're plugging into an existing WirelessHART infrastructure that they had already in place for process control, not process monitoring. And they were very happy that they were able to plug in, look at the device. It was very familiar. If they had any questions, they could reach out to us. They could reach out to the gateway manufacturer, and both of us were able to support and work together to resolve any questions they might have had. They actually had a situation where when they initially put together the network, they were funneling all of the detectors through 2 detectors. They created a choke point, and the gateway was giving error messages about devices, not connecting, and they would immediately know that they needed to go address something. And by having both manufacturers of the gateway and the device there, we were able to quickly determine that there was a choke point. And by putting in a couple of more devices and repeaters, they're able to eliminate that, and the mesh became better. And now they're looking at 98, 99% uptime for the network without those errors. So there's a huge advantage to kind of being within that ecosystem of multiple manufacturers, with an open standard that you can then go do the registration with and testing to do interoperability. And there's a huge advantage of that. So I wanted to just give a couple examples of rapidly opening area where customers who were reluctant at first because of concerns of wireless are now actively seeking wireless devices because of the advantages it brings. The interoperability, the time saved, the money saved, and the scalability, just to get more data. So with that, I mean, I'll turn it back to Paul, and we can, I guess the next is the questions. Thank you.
Wow, you guys are great. Can you go back to the Q&A slide, Robert? You guys are great. You talk about the value of registration. You talk about multi-vendor interoperability. You talk about all the things that we kind of like preach to our membership over and over. Again, I want to thank you for participating in this. We're really short on time. I've tried to answer most of the questions that are in the box while we were doing this, so I think I got most of them. We are recording this, and you will be able to see it and watch it, and reference it to your coworkers if they were unable to attend. You'll see an email on the link. I do have one closing question that I kind of want to ask, and I'll give you, each one of you guys has about 30 seconds to answer it, or we'll run out of time. So, kind of if you knew then what I know now is the sort of the question. So when you were in the development phase of your device and working with Robert, or developing your own, you're doing your engineering system, what would you have, what kind of things do you wish that you had thought of while you were doing that might have made your process a little bit easier? Maybe it's maybe it's battery life, maybe it's FCC certifications, maybe there's the use cases of where it's actually going to be used. What do you wish you could have known more? And Robert, what do you wish that customers that walk into your door had thought more about before they walk into your door? Or where do you find the gaps in their knowledge? 30 seconds each. Who wants to go first?
I'll go first. Battery life. That's always a big one. Battery life is always a big one because it takes a lot of planning from the very get-go, from the product definition. You have to really plan on what really know how your instrument is going to operate and what data is going to transmit and how it's going to read the sensors that are connected to the instruments to control the actuators. That is one milestone or phase of the design where a lot of effort typically goes in, and it requires deep embedded firmware knowledge and hardware knowledge. So that's why a lot of the people, it's a time-consuming phase of the development project. So I would highly recommend that when you embark down this road of developing an instrument, that you very carefully plan for battery life from the very get-go. And Paul, we're not under. It was my impression that we have another 15 minutes for the Q&A session.
Oh, good. Well, let's do it then.
Yeah. I was proud that we were right on time because we had planned on an hour, so we have an hour.
I thought we ended at 9, but this is great. Okay, so you now can have another 30 seconds.
Well, I'll turn it over to Philippe or Chris or whoever wants to.
Yeah.
Go ahead, Philippe.
Yeah, go in order. so basically, on our side, the first WirelessHART device that we launched was in 2011, which is 11 years ago. And as you can imagine, we have changed a lot of device over the time. One of them was Robert was highlighting, is the battery life. So we actually changed our design to a single battery to a double battery to improve. We improved the algorithm to use less energy. If we look theoretically, the calculation that was done on the device, it could last for 10, 12 years. But that's in the lab theoretically. So we'll see on the field now that we go to 4 to 6 years easily, and which is a big game changer. Our first device was not hard register, and we saw that as weakness. It was better, especially the feedback from the customer. They wanted something that is with full compliance, fully tested, approved, that there's no risk for their network. And that's why we went, now the latest generation is fully hard registered. So that was kind of one of the steps that we took that we didn't have before. Maybe one thing I would just highlight on more generic is the wireless. 10, 15 years ago, a lot of people were more reluctant to go wireless. A lot of questions about cybersecurity. They don't want to be hacked. It's now people understand, and even if we were preaching, the WirelessHART is secure and there's no risk, and we've not seen any breach, so far until now. It's pretty secure. But it took a while for customers to adopt wireless technologies. Because of that, everything you hear on TV, radio about hacker, but now it's something is way more adopted, that people are really looking, knowing that, oh yeah, I can have wireless devices. I can have the UE and any Armstrong and other WirelessHART device. They will talk to each other, and they will all go to the gateway securely, and that's what people like. They are not stuck with one vendor. They can use multiple vendors for multiple applications on the same gateway.
Okay, Chris?
Yeah, we were fortunate to have a good partner to help us and work on the battery life. But one of the things that we probably would have benefited from knowing earlier on was how are end users or operators going to actually utilize information that's available on WirelessHART that isn't necessarily always thought of. You got diagnostics on sensors and devices and stuff, and often when you design those, you design them for yourself without really thinking about what the benefit is for the end user to know that same information if they need it. And being able to understand how customers can access that, whether that's through WirelessHART directly from the gateway or with a handheld device, or even a PC connected to it, having that also part of your interoperability plan and your applications that you provide for the end user would have been hugely beneficial, because it answers a lot of questions that customers might have about reliability, or can I trust a sensor, or that stuff. You're like, oh yeah, I can help you with that, but I need you to go do these 4 other steps that our engineers know how to do to get this information, making that easily available. Now, we've adapted, we've done a better job of it now, but knowing that at the front end, all that information that's good for your engineers would probably be very helpful for your services teams after the fact too. So you might want to make that stuff available.
Okay, good. That's good. So another question that's coming up is, and this kind of, to me, it kind of relates to not only technology, but the overall ecosystem of a process automation system. And it has to do with some of the emerging technologies in wireless that frankly have a very large marketing voice and a lot of buzz. Things like Bluetooth Low Energy and Low Ra WAN and 5G and stuff like that. Do you see those as technologies that are viable in the process automation space and instruments and things such as like what you guys do? Or is there another place for them, and how do they fit into the overall ecosystem of process automation? Anybody?
It's a good question. I wish I had a crystal ball to know what the future is, and to know what to do next. We see the technologies mainly right now institutional application or home automation. As far as the industrial processes, right now there's still like I was saying before, a lot of question about security and reliability. Mm-hmm. But everything is evolving, and you never know what could come tomorrow.
When you say institutional, what do you mean? What do you mean by institutional, Philippe?
So institutional, it's more like more your buildings, healthcare, okay, hospitality. So more that kind of industry against industrial, which is more food, pharma, refinery, chemical.
Got it. Got it.
Yeah, there's going to be a trade-off in layers of robustness of what kind of network you need. If you think about a widespread infrastructure that's spread over mountains and stuff and in open space, a protocol like LoRaWAN might be good because you're working in a sub-gigahertz frequency, but you also have a lower bandwidth, so you can't get as much data. You also have kind of not the checks and balances and stuff that you get out of something like WirelessHART. But WirelessHART works really well because you're 2.4, you're inside a plant, you're hopping from device to device if you need to. So there's different advantages both from the physical and the application layer, from security to data. The advantages of LoRaWAN are also being seen within plants because of the fact that you can get away with, and Robert probably doesn't want to hear this, fewer gateways, but at the same time, you're limited in what data you can provide or the speed of that data. So if it's critical information or whatnot, you might be limited in that regard. So there's a lot of trade-offs, and it's the crystal ball thing that Robert was saying, that it's just interesting. If somebody told me, like Philippe was saying 5, 10, 12 years ago, that somebody's going to do a wireless gas detector for safety applications, I would say no customer would ever buy it, even if it worked really well. And that's all changing very rapidly. So I think we're over the next 10 years, it's going to be real interesting to see what all the IoT stuff brings.
Robert, do you have anything to add there?
Yeah, I mean, we get this question all the time. Just we are in the wireless business, so and we are participating in a lot of different standards, and traditionally that's what we've been doing. So yeah, LoRa, I mean, as you mentioned, Paul, there are a few candidates out there that a lot of folks are looking into, LoRa being one, NB-IoT being a second technology that's been gaining a lot of ground, and also BLE, Bluetooth Low Energy, and to be more specific, not just BLE, but also BLE Mesh, which is a new Bluetooth Low Energy profile that's being promoted heavily lately. Now, I think Chris kind of already mentioned the pluses and minuses of LoRa. You get range, but you don't get the data rate. So for particular use cases, LoRa is, in my opinion, is definitely a viable option, but not when you're trying to publish data every second, or you're trying to do any kind of control. That would be close to impossible over LoRa. But it's definitely a suitable technology for supervisory monitoring, where very extended range, miles and miles of range are important, but data rate is not, and latency is not necessarily an important requirement. Now, with LoRa, you also need to have the backend infrastructure. So you need to have what's called if I call correctly, a network server and an application server. So it's a bit more. You have to kind of think out. You have to think the solution from a security point of view as well. You need to have a gateway that might or might not have the network server and the joint server, and then you need an application server, and that typically resides in the cloud. So it's you also have to keep in consideration the backend side of the LoRa piece, not just the wireless connectivity link. But yeah, now when it comes to NB-IoT or LTM, which are really cellular technologies, right? We're crossing here 4G, 5G boundaries. Obviously viable technologies. You do have to pay though for that data because it will come in over a cellular link. So there is a contract associated with that, and also it's a point-to-point technology. So there's no redundancy, there's no mesh routing, and also with the emergence of 5G now, and this what is it called, low latency guaranteed connectivity of 5G that will allow you to go as low as 10 milliseconds. That's what they're claiming at this point. Yeah, that does open quite a new can of worms in terms of what you can do, because now you can do much higher or accommodate use cases that require much higher data rates or bandwidth as well as latency. But as of right now, and I think for the foreseeable future, WirelessHART will definitely be the primary candidate when it comes to ensuring guaranteeing these latencies, mesh connectivity. That's what it was designed for, right?
Yeah.
It's designed top to bottom for process automation.
Sorry, you guys did a great job of talking about kind of the instrument side of it and maybe the wireless infrastructure. I was also referring to the overall ecosystem, the registration process, the multi-vendor interoperability, the integration into, the ability to integrate through DDs and other things into control systems and asset management systems, and kind of the whole package that you get with a WirelessHART product, above and beyond just the radio and the instrument itself. So I think that's something that bears consideration, particularly in process automation applications. So.
Yeah, that's a very, very good point, Paul. So yeah, if you can easily design an instrument that would use LoRa or NB-IoT, but what do you do with the data?
Yeah, exactly. Exactly.
I mean, you can, as I mentioned earlier, you have to, as you said, you have to keep in consideration, you have to consider the system side as well, your gateways and then the system side, which is very important.
Mm-hmm. Yeah, and you brought up an interesting point that I didn't necessarily think about, that in some of these networks like 5G networks and other things, you're paying for the data. You're paying a fee for every megabyte of data that's being delivered and things like that. So yeah, interesting. Okay, well, I think we're just about out of time, and I'm glad that somebody reminded me that a couple of you reminded me that we had 15 more minutes, because I think we got in some good content there. Again, we videotaped this, so it's ready. You'll be able to watch it. There's a couple of handouts that are available if you're in attendance. I want to thank our speakers again. You did a great job, and I really appreciate it. And Robert, as always, kudos to you for making a fairly complicated development process sound not all that complicated. Maybe you might want to make it sound more complicated. You get more people that way.
Complicated enough as it is, Paul.
All righty. Y'all have a good day, and for those of you that are in the U.S., have a happy 4th of July. Take care. Bye.
Yes.